as many of these kinds of problems today as we can. We're going to continue on with the finding all real zeros. We're going to find all of our solutions. We're even going to find the not real ones today too. Oh, snap. So this is the same kind of thing that we did yesterday. So write this function rule down. These are going to be those ones that take a very long amount of time and a very long amount of space. Like we might get, like we'll get 2, maybe 3 of these today.
That's the scariest thing of all.
How long they are?
Yeah.
All right. So first thing we're going to do is we're going to start with Descartes, where we figure out how many positive, how many negative, all that jazz. So we're going to start with how many times does it change sign as it is? I'm just going to give us some more space here. How many times does the sign change? 3 times. Which means how many positive roots do we have? 3 or 1 positive roots. Then to check about our negative roots, that's when we substitute in the opposite of x. So we're going to do f of the opposite of x. Does the sign change if we take the opposite of x to the 4th? No. Because if I take this to the 4th, it's still going to wind up positive. Is this sign going to change when we have the opposite of x cubed? Yes. Is this sign going to change when we have the opposite of x squared? No, it is not. Is this sign going to change? Yes, because the opposite of x will make this minus 4x. Minus 120. So how many sign changes do we have on the opposite of x? 1. So how many negative roots do we have? So we're going to have 1 negative root and 3 or 1 positive roots. So we have a lot of options here. So that's our next step, is to make our list of all possible real roots. And this is going to be a big list. Because our p is what value? 120. And our q is what value? 1. So we need the list of all factors of 120. And I tend to think of it in like the multiplicative pairs. That's the way my brain does, where I go like 1 times 120, 2 times 60. So you don't have to write them in numerical order. So if you look at like my notes or my answer keys that I've written, they're written in very what looks like scrambled orders, because I do them as multiplicative pairs. So our list of factors of p, I'm just going to go sideways from here. So 120 times 1. What else do we have that's a factor of 120? 2 and 60. What else? 3 and 40. 4 and 30. 5 and 24. 6 and 20. Oh, hang on a second. Keep going with your list. Pieszki. Yeah. Right. Right. Understood. I will not. Understood. Right.
I like to do it all the small.
Understood. Bye. Okay. So what other ones did we have? 8 and 15, 10 and 12. And that's our full list of factors of 120. With our Q being 1, this is also our list of all possible options if we add plus or minus in front of all of them. So our list of all possible, I'm going to rewrite it because I didn't put enough space to put that in there. So our all possibles are plus and minus 120, plus and minus 1, plus and minus 2, plus and minus 60, plus or minus 3, plus or minus 40. So I don't care if you put these in numerical order. I do not care if they are scrambled. I do not care if they're in this order. I do not care what order you put. I don't care. I am happy to search through your list and make sure we have all the things when we're looking at stuff. And if you want to put the plus or minus in your initial list of P, I'm okay with that too. You don't have to make a separate list for your all. But this gives our all possible options. At this point, do we have any way to narrow down where to start? Blind guess and check. We pick one that we want to do and substitute it in. So let's try 1. That's the first one I heard. So let's see if f of 1 is a root. Harsh. But you're right. It doesn't work. So 1 to the 4th is 1. 1 cubed, 1. Minus 26 plus 4 minus 120. Is that going to be 0? No. Does it matter what number it actually is?
Yeah.
No. All we care is if it's 0. All we care is if it's 0. So we know it's not positive 1. Let's see if negative 1 works. 1 minus 1 minus 26 minus 4 minus 120. Is that going to be 0? No. So we know it's not the ones. And you can use your list and cross stuff off as we eliminate it out. That's fine. Yes, dear.
Do you actually know which one works?
I do.
You want to hint us to the actual correct?
Nope. Just know that when we do have things like assessments, our possible list is not going to be this long.
How long? What's the max?
We tend to do things that'll have 5 to
Okay.
10, maybe 10 factors most. 10 at most. This has a gazillion.
You have to do this every time.
This is
Until you get 1 factor.
until we get 1.
Okay. Come on, 2.
Let's check the 2s, see if the 2s work. And you guys can you don't have to go in numerical order. You can do whatever you want. And also, especially with lists this long, with operations this big, use calculators. It's okay. On the homework, I'm not watching you anyway. Just saying. So feel free, I do. I use it. The operations will not be this much when it comes to things like assessments. So let's check 2. 2 is going to give us 16 plus 18 minus 26 times 4. Yeah. Plus 8 minus 120. Any chance that guy's going to be 0? 8, sorry. That's what happens when I'm talking and writing at the same time. Any chance that's going to be 0?
Yeah.
Okay, let's get all the way down to value and see what you think, Tommy.
Yeah.
What you got? What's that going to equal, Tommy?
100 or something.
So is that 0?
Oh, no.
No. Does it matter what actual answer it is? No. All I care is it 0?
No.
Nope. Move on with our lives. So it's not 2. Let's try negative 2, because then maybe I can cross something out.
You gotta do this to all of them?
Until we find one. We got to find something. So let's try negative 2, because then I can cross the 2's out if it doesn't work. So we'll have 16 minus 8 minus 26 times 4, which is actually 104, minus 8 minus 120. Is that going to be 0?
No.
Do I care what it really is?
No.
No. Move on with our lives. We know it's not in the 2's.
I think 5 is gonna be the one.
So let's jump and check 5. We can do that. Let's jump and check 5. It's totally fine. So we're substituting it in. So we have 5 to the 4th, which is what? 5 to the 4th is 625.
Guys, I just made that up.
I was going to say you did 5 times 100, kind of.
25 is, I thought it was 125.
125 and then times 5 again, because we're to the 4th.
Okay. No.
All right, so then we're going to take our 5 times our x cubed. 5 to the 3rd gives us plus 125. (26) times 25 gives us minus 650. Plus 20 minus 120.
Yeah.
So those are looking really close. So let's get that to an actual answer. Let's see what's going on here.
Yeah, nice.
It's 0. Yeah, I'm so smart.
Oh, it worked.
He lucked us into a root. Good job, Tommy. So 5 is a root. So then what we're going to do is we're going to take 5 and we're going to divide it out and see if that helps us narrow things down, because that would be super handy. So we're going to take and we're going to use our synthetic division. So our coefficients of 1, 1, negative 26, 4, and negative 120. And we are going to divide out 5. So our first term always drops. We're going to have 5 here. Then we add, gives us 6. What goes here? 30. What goes below that? 4. Goes below this 4? 20. So what goes below? 24. Which gives us 120, which gives us 0. Yay, means we did it right. So that gives us now our new polynomial of x cubed plus 6x squared plus 4x plus 24. Can we factor this yet? Do I have to go back to my giant list of options? Can I maybe narrow it down?
Yeah.
Because we have a new p-value. What's our new p? 24. So our answer has to now be a factor of 24. So I have a whole lot of things in that list I can eliminate out. So I know it's not going to be 120 because that is definitely not a factor of 24. I know it's not going to be 60. That is not a factor of 24. I know it's not going to be 40. That is not a factor of 24. Or 30. Or 20. Or 15. Or 10. Or 5.
Wait, why are you crossing it up?
And then,
Because it's not a factor of 24, it cannot be one of our roots.
so what about the ones we already crossed out? Like
They're
before?
still not, they still aren't roots.
Yeah.
So once I have one of them, it helps me eliminate a whole lot of the options. So we're down to, and if you want to, you can like rewrite it so that we see.
-6.
We're down to plus and minus 3, plus and minus 4, plus and minus 24, plus or minus 6, plus or minus 8, and plus or minus 12. So we're down to these few. So it makes significantly fewer options just by finding one of them. But since we can't factor yet, we go right back into our guess and check situation.
-6.
What makes you think that, Tommy?
Cause you know, I mean, mental math.
Just because you got your picture.
Because you got the 4,
Don't put your name. You know, like,
Okay, so I see a logic behind it. We've got a 4, 6, 24, so maybe we're looking at some of the other numbers. So we can try 6.
No, -6.
Well, I'm gonna do 6 first. We can work with the 6s, but I'm not just gonna pop into the negative one. And we don't have to go back up to the original formula. We can use this one here. Smaller numbers, we like that. 6 to the 3rd is 216. 6 times 6 squared, again, gives us 216. 4 times 6 gives us 24. And 24. That one is definitely not going to be 0 because those are all positive numbers. Let's look at -6. So we have negative 216 plus 216 minus 24 plus 24.
I don't know.
Tommy, if you are genuinely guessing, go buy a lotto ticket. If you're 18. Because you're just lucking yourself into roots right here. Yes, dear.
Okay, so like, how did you get the plus and minus 3 plus minus 4 again? You just took the factor of
I took all these factors up here, and I crossed out the ones that were not factors of 24. And I just rewrote it down here so I didn't have to keep scrolling back up. You can always rewrite your list of like the factors of 24 and just cross out the ones you've already gone through. Absolutely valid. I'm just lazy. And I will take the lazy way when I can. All right, so then we've got -6 as a factor. So we're going to divide it out. So we're going to take our -6 root. Factor would be the x minus 6. Root. So we have our 1, 6, 4, 24. The 1 drops. -6 gives us 0. which means this is 0 and this is 4. Negative 24 and 0. So our remaining polynomial that we have left over, x squared plus 4. There's no x's. Can we factor that? Is that a difference of squares? No. It's imaginary. Our roots are going to be imaginary here. So think about if we set this equal to 0, to find our solutions, our roots, subtract 4 from both sides. X squared equals negative 4. What's our x? I'm going to be specific. Plus or minus 2i. So our roots for this whole function, where it said find all roots, are, I'm going to get a big marker here. And we're going to get a nice bright color. We have 5, negative 6, and plus or minus 2i. These are our roots, or zeros, solutions, intercepts. Yes, dear.
So it said, remember at the beginning we did like negative can only go like beyond the 1. So how can we be a plus or minus 2 and a negative side?
Because the plus or minus 2i is not real. It's complex. So the positive and negative only deals with the real roots. So we only have 1 positive root, 1 negative root, and 2 complex roots. So 2 non-real. So if we have imaginary roots, it doesn't affect the ones we found in the Descartes, because those are only real. So we had 1 positive, 1 negative, and 2 complex roots, or imaginary roots, or not real roots, however you want to word it. They mean the same thing.
This one's good. This is a great picture.
If we wind up with some time where we have no negative roots or no positive roots, it eliminates half of our all possible options.
Yeah.
So it has the opportunity to save us a ton of work. Okay?
So if it says the 0, then we don't use
Then we don't have to use any of the negatives to substitute in. And then also if we wind up with an even number of changes, we know we might not have any positive roots, we might not have any negative roots, so we could focus on substituting the negative to save us in case we don't have any positive roots or any negative roots.
What happens if instead of 0 and 0 negative and it's all just complex?
That would be very, very mean. I've honestly never seen one like that.
Okay.
Because that's horrendously cruel.
What do you do? Just cry.
You would have to hope that it's not all complex roots. And like, yeah, go on, hope. Go ahead. Yeah. Yep. It'd be 2 or 0. It always comes down by even numbers. Okay? So it's 3 or 1, 2 or 0, 4, 2 or 0. Yeah. No, good question, good question. Okay. No. We go try and do another one. Okay? Let's do... All right, it has fewer options. Let's do this one. It's a 5th, but it's fewer options. The other one I have is a 4th root, but it has very large coefficients. So it has a significantly large number of options, and they're all fractions. So we'll do this one. It's a 5th root. We're going to find all solutions. Oop. Sorry, I meant to do right first. There we go, just to give us space. So x to the 5th minus 18x cubed plus 30x squared minus 19x plus 30. Start with Descartes. Our number of positive roots. Ooh, wrong pen. How many changes do we have on the positive roots? 4. So how many positive solutions are we going to have? 4 or 2 or 0. So then we're going to do our negative. See what happens. So if I substitute in the opposite of x, we're going to have the opposite x to the 5th. This sign's going to change as well. Opposite of 18x cubed. Does this sign change? Nope. Does this sign change? And does this sign change? No. So how many sign changes do we have here? 1. So we know we're going to have 1 negative root. So when we're looking at our list of all possible solutions, you can absolutely try the positive roots. There's absolutely chances of it. We do know for a fact we have 1 negative root. For a fact, there is 1. So you can use this to help kind of lock in where we need to focus, because we might have no real roots. We might have 4 real roots. So it's up to you if you want to take that gamble on the positive real roots. We know for sure there's 1 negative real root. So let's make our list of all possible options. What is our value of P? 30. What is our value of Q? 1. So when our Q is 1, all we have to do is list out our factors of 30. If we had a Q that wasn't 1, we'd have to do the fraction-y thing for our giant list. So our factors of 30 are what?
1, 2, 3, 5, 6.
So plus and minus 1. I'm going to do my multiplication pairs. And 30. 2 and 15. What else? 3 and 10. Anything else? 5 and 6. So those are our all possible options. Then we're just going to start testing stuff.
2.
Should we do negatives? Because there's
It's entirely up to you guys. You can pick whatever you guys want to substitute in. So Tommy, you're being overwritten. -1. I've heard it from 3 people. If you want to do it, Tommy, you go for it, Tommy, and then you work your way through. You should wind up with the exact same answers. Okay? You're fine. So we're going to have -1 plus 18 plus 30 plus 19 plus 30. Is that going to be 0? No. So we know it's not -1. What do you want to do next? You want to do positive 2 or -2? We can do whatever you guys want. I heard -2, so let's do it. So we have -32. This is going to be positive 144. Positive 120. Positive 19 times 2. 38. Plus 30. Is that one going to be 0? Nope, so it's not negative 2.
It's 2.
Because they called it out. I'm just going with what they're calling out. We
said
know
2.
for sure we have a negative root. That's why I think people are focusing on it. So which one do you want to do next? Positive 2. Let's go for it. You guys can do whatever you want to do. Like, it genuinely does not matter what order we go in. So f of 2 was the next one I heard. So we're going to have positive 32. Then we'll have negative 144. Positive 120. Negative 38. Positive 30. What's that equal?
0.
0. We found a factor, or found a root. Keep saying factor. So 2 is a root. It doesn't matter what order you go in to get there. You can go through whatever we need to. But we know 2 is a root. So we're going to divide out 2. When we set up our synthetic division, we're going to be super duper careful, because what are my coefficients going across? 1, 0. Good, we noticed that. There's no x to the 4th. Minus 18, positive 30, negative 19, positive 30. So 1 drops. 1 times 2 is 2. Add them down. We're going to work our way across. Negative 14. Negative 28, which gives us a positive 2, a positive 4, a negative 15, and our negative 30. We wind up with a remainder of 0, which is what we need to have. That proves that we did it right. So here we have our new polynomial. We're at minus 15. We've got a 2x, 14x squared, 2x cubed, and x to the 4th. And we know we have a root at 2. So I'm going to just put that up there. So now I have a new p-value, and we can go back to our list of all possible options, and we can cancel at least one out, a couple of them, because our root has to be a factor of 15. So what can we eliminate out of our options? 30, 10, 6, 2. We're not going to have another root of 2. 10. That's okay. He was working on his paper. It's okay. We'll go through it. So the negative 1 is still not going to be a root. But now we have a smaller list of options now.
I think 3.
You think 3?
Yeah.
Do you guys want to do 3, or are we disbelieving Tommy?
Yeah, 3.
All right, we can do 3. Let's find f of 3. Three to the 4th is 81. 2 times 3 to the 3rd is 54. Minus 14 times 3 squared is minus 126. Plus 2 times 3 is 6, minus 15.
0.
So 3 is a root.
I think he should be kicked out of class.
He's either working ahead or he's incredibly lucky. Eden,
I'm working ahead, you know.
I kind of figured that's what it was.
Stay ahead of the scholars.
So 3 is a root. So I can put that in my list up here. So we need to divide 3 out. So we're going to take our coefficients. We've got our 1, 2, minus 14, 2, and minus 15. Our 1 drops. 1 times 3 is 3. Add. 5 times 3 is 15, and then we're going to add. So our synthetic division should wind up looking like this. One, 5, 1, 5. What that really is x cubed plus 5x squared plus x plus 5. And again, we can narrow down our choices. Because it has to be a factor of 5. So what can we eliminate out of our options? We can eliminate out 3. We can eliminate out 15. We're down to just 1 and 5. That's all we got left. Positive 1, because we've even already done the negative 1. So positive 1 and 5 and negative 5. We're down to 3 options. And we still need one more root, because I cannot factor out x cubed. Because we have to have a negative root, and we haven't had one yet. We have 2 positive roots. So we don't even have to look super hard. I have the options left of 1, 5, and negative 5. And we need a negative root according to our Descartes.
Negative 1.
We already did negative 1, and we tested that. It wasn't an option.
I don't know.
So process of elimination, what's the only negative we have left? Negative 5. We can even hop straight into our long division and see if that works and saves ourselves a step. So let's try our negative 5. So that these kind of situations are where the Descartes comes in handy. It helps us eliminate some of our options. So we have our 1, 5, 1, 5. And we're going to eliminate out 0. 0, 1, and negative 5. Lolo. So what we wind up with our remainder of 0, is x squared plus 1. I'm going to go add my negative 5 to my list at the top. So if we're left with x squared plus 1, what are our last roots? Plus and minus I. If you need to, set it equal to 0. Totally fine. X squared plus 1 equals 0. And find our solutions. X squared equals negative 1. So x equals plus or minus I. Plus and minus I. So these take a humongous amount of space and humongous amount of time, which is why we only got through 2 of them today. But we got all the way up to a 5th. We did a power of 5, and we found all our solutions. No. We're moving on to other things tomorrow. Okay? We are gonna have a quiz on Thursday. Just as a reminder.
On Thursday?
Yeah. Dude, pink paper has literally all of them written out with dates, what we're doing and when. Including when the quizzes are. Have a great rest of your day. Have a happy Halloween. Make good choices tonight, please. Make good choices.